IMPS/IMVs stands for Intensity Modulated Photocurrent and Photovoltage Spectroscopy. Instytut Fotonowy has launched a new setup for IMPS/IMVs. Why? Because you need to determine several dynamic parameters of your photovoltaic samples. Look, photons can excite electron-hole pairs anywhere in the sample. The pairs created in the bulk quickly disappear due to recombination. In the space charge region, at the sample's surface, the built-in electric field prevents recombination. Electron-hole pairs created there have a greater chance to survive and form a photocurrent. If the sample is an N-type semiconductor and the electric field is directed towards the surface, the electron concentration rises just outside the space charge region, and their diffusion to the other side of the sample begins. The average time to cross the bulk is called transport time. Some of the electrons are lost along the way when they meet a minority carrier, a hole. The average hole lifetime is the recombination time. It describes the balance between pair creation and recombination. How? These two related experiments rely on measurements of short-circuit current and open-circuit potential, respectively, when the sample is excited by a modulated light. In order to do that, just place the sample in an electrochemical cell or any other holder in the sample chamber. Connect the electrodes. Define the experiment parameters such as frequency range, wavelength, and light intensity. The output signal phase shift may be displayed in several ways. You have to find the minimum in the Nicolaus plot. 1 over omega minimum in the IMPS plot gives the transport time. And from the IMVs plot, the recombination time is revealed. Then type in your sample thickness to calculate two parameters that describe the electron's diffusion, diffusion coefficient, and effective diffusion length. Some samples, like perovskites, are unstable. Their properties change during the frequency sweep. So, the beginning of the sweep probes a slightly different sample than its end. In our IMPS/IMVs, we have a solution to that difficulty. The instrument can apply all frequencies of interest at the same time. This achieves two goals: shortens the measurement time and makes the acquired spectra self-consistent. Anything else? Yes. Place your sample in your own IMPS/IMVs setup and make amazing experiments. Good luck! Instytut Fotonowy.